Hello and welcome to this month's RSK Technical Talk. My name is Jim Southern and I'm an Associate Director at Structural Soils, which is an RSK Group company. I've been working in ground investigation for over 35 years, the last 22 of which have been at Structural Soils, where I'm currently the engineering lead for the Bristol office. So I'd like to introduce you to my colleague Eric Downey, who's going to draw upon his 31 years of GI experience to present the talk today, which is entitled The Correct Tool for the Job. So it's going to introduce us to the principal investigation techniques available to the GI practitioner, set out the benefits and limitations of each one, and explain the circumstances where each might be used. So just before Eric starts, we'll run through a couple of housekeeping points. So the first thing is everybody's muted throughout the talk. You don't get a chance to say anything, unfortunately. If you want to ask any questions, you can type these into the question box, which you should have up on your screen. And at the end of the talk, we'll try and answer as many of the questions as possible. And then the final point is, shortly after the webinar is finished, you will all receive an emailed feedback survey, and would be very grateful if you could respond to that. So, Eric, away you go.
Thank you very much. I will crack on. So 2 seconds. Right. Thank you very much, Jim, for the nice introduction. Just a very brief overview of Structural Soils first. We have 8 UK offices that we run our site investigation practices from. We have 4 UKAS accredited lab, and one of them being a red lab, which I'll talk a little bit about later, based in our Castleford team. And we've been going for nearly 60 years. So we've got a breadth of experience and we're happy to share it with you all today. So how do we undertake our work? Well, we use a British standard BS 5930, Code of Practice Site Investigation 2015. This is an essential document, and this is how we undertake all of our work. This is the Bible of all of the work that we undertake. In summary, we are undertaking, or we are assessing the ground risk for our clients, and the more ground risk we can undertake, the better that we can offer this to our clients and allow for unforeseen ground conditions is reduced. However, we do actually have to work within our client's budget and their program. So we have a number of sort of constraints on that. It has been sort of worked out that 50% of construction projects overrun due to unforeseen ground conditions. So our job is to try and find those unforeseen ground conditions. So we have a number of tools at our disposal, and I will be talking very briefly over those, but we're more than happy for you to contact us to talk about them in more detail at another time. So one of the first sort of tools we have is our desk study, and this is where we sort of look at all of the published data that pertains to that site. So we would look at anything that's already published, so old historical maps, sort of former anecdotal evidence from the council, and we will design our ground investigation as best we can from this information. But we need as much information that we can get our hands on, and that will allow us to offer our clients the best practice. What we do have within Structural Soils is that we have a GIS database of all of the history of all of our sites across the country. And this is on top of the British Geological Survey. So we can identify in a lot more detail on each particular site the most appropriate equipment and drilling apparatus on those jobs. One of the sort of tools that we have at our disposal, not within Structural Soils, but within our parent group, our RSK, is Geophysics. And this is a fantastic tool, a non-intrusive tool, and it gives an overview of the ground conditions that we may have on the site. And we can also target our ground investigation better by using this. So very briefly, in this pink area that you can see, we have basically a massive concrete slab, and we can concentrate our ground investigation in that area to delineate it. And then we have some made ground adjacent to it, and then we've got some bluey areas over here where we can reduce the amount of investigation techniques that we may want to use. So there's lots of different techniques, and again, I won't be talking about those, we just don't have enough time. So what I'd like to start with is talk about the cable percussion drilling. This methodology has been around since Roman times. In a nutshell, we have an engine which lifts and lowers a large weight. This is used for overburden material such as sands, gravels, clays, and chalk. We can get into some Mercia mudstone as well, some of the weathered fraction of that. It's a very versatile piece of equipment. It's fast, it's effective, it's relatively cheap, and this is why it is used quite extensively in the ground investigation industry because of its cost effectiveness. We can drill up to 60 meters in the right ground conditions, but one thing that I would like to add to this is that whenever you're on site, please ensure that the driller has these side stays on, and also it's mandatory from the British Drilling Association to have a whip restraining bar that is in operation at all times. This will prevent the rope from coming out and causing accidents with the driller. So that is a very important part. So again, if you do notice it that's not on, please ask your driller to please put that back on. So there's a range of different casing sizes, and we can get down to, as I said, a reasonable depth of up to 60 meters, depending on the ground conditions. It is a very useful tool. With the cabled percussion drilling, we can get this into some quite small areas. The photo on the left is actually in Bristol, the Bristol Beacon. We got into the basement to try and get some investigation information from the ground here. What we actually did is, this one's actually sort of powered by diesel, but you can get electric ones. And again, we just need to make sure there's a good airflow running through the site. We do need a reasonable amount of space for this, and the more space we have, the faster we can drill, so the cheaper it will be for the client at the end of the day. So moving very briefly, very quickly on to rotary drilling. There are a number of different sizes of rigs available to us. This one is our standard size. It's a Komatsu 205. It does need a reasonable amount of space. I would say it's sort of 10 meter by 12 meter sort of space available. This will allow us to work effectively. The rotary rig actually has two sort of devices at the top here, a rotary head and a Krupp hammer. The Krupp hammer is used to power in the casing and some window sample tubes into the overburden, so this sandy clays and gravelly clays. It doesn't like working in solid gravels or solid sand. That it does cause some issues, so we do need to check the ground conditions to make sure this is the right equipment. If the overburden is too sandy or too gravelly, we'll have to use cable percussion drilling, because that is the most effective tool for this. But we've got an SPT hammer here. This allows us to undertake standard penetration testing, and this will give us an indication of the strength of the ground as we progress through the borehole. So we can get up to 100 meters, not necessarily with this 205. We'll probably get to 40 or 50 meters with the 205, but if we're looking at the Komatsu 600 series, we can get a lot deeper with that. So again, depending on the site constraints and the depth of the client's requirements, we will choose the size of the rig that suits the job that we need. Rather like the cable percussion cut down version, we can get our rotary rigs into quite tight spots. This on the photo on the left-hand side is Queen Street Tunnel in Glasgow, and we were able to get the rotary drilling rig into the forefoot and able to drill quite successfully over a possession at Hogmanay a few years ago. And on the right-hand side here, we need to protect the environment or the atmosphere that we're working in, so we had an exhaust fume on there. So again, just let us know exactly where we are working, and we'll do our best to get there. Very briefly, Structural Soils were one of the first ground investigation contractors to bring rotary and sonic drilling on the same rig. So we've got a sonic head here and a separate rotary head, which you can't actually see very clearly in this photo. But the sonic drilling is certainly getting more and more used within our operations. We've used it very successfully. It's best for dense gravels and dense sand. It's like a knife through butter. It works extremely well. It is more expensive than standard rotary, but if you've got a large site with a number of different holes on it, this again would be the perfect tool for the job. So once we get through the overburden and hit the rock, we can just change the rotary, the sonic head for the rotary head, and then carry on with the rotary head. That means that we've got one setup on site, and it's a lot quicker for our client. So obviously it will be cost effective. If your site has a slope on it, we can use a slope climbing rig. Our sister company, Central Alliance, has a slope climbing rig. It's also got a mule, which is an adjacent platform which articulates out, and it allows the driller just a bit more space to run his rods out and work effectively and safely on there. There are some constraints with this. It does need to be a nice clear surface. Vegetation needs to be almost at ground level, and depending on what you've got at the bottom of the slope, we do need to anchor the rig so it doesn't move. So we've got a factor of safety for that. So, and it can work on 40 to 45 degree angle slopes. So again, it's a great bit of kit if you have an issue with a failing slope. What I'd also like to just point out is that some of our clients are asking us to work in very low soft ground conditions. So we have designed some equipment to work effectively in that. So sometimes our wind farm operations are in very remote areas with lots of peat around. So these Caterpillar tracks can work in an area of less than 2 psi. So we've got a support tractor as well with the compressor on, or we've got and the casing as well. So we've got the rig on one unit, and then the casing and the compressor on the second, and then it will tow a water bowser. So it's a very effective bit of kit. We've also invested quite heavily in these supercats. I think we've got 3 or 4 of them in our arsenal, and we've got one with a window sample rig mounted on the back. So we're actually able to work in intertidal areas again very effectively. And also one of them is a sort of shunter vehicle, and so we can pull a cable percussion rig around and into some quite tricky access areas. So once we've drilled our borehole, we need to make sure we get as much information out of it as possible. So what we'd like to do is run some geologging tools down there. This can be done with the rig being in situ, or if the rig needs to move on and go to another borehole and carry on drilling, we can run it with a tripod and run the tools up and down the borehole without the rig. So we're minimizing the downtime of the rig. However, sometimes with a packer testing and with HBD testing, unfortunately, the rig does need to be in situ. So again, we need to basically keep a handle on the program on that so that we understand how things are going. Our window sample rig is the next sort of tool in our toolbox. This is a fantastic bit of kit. It's powered by hydraulics. And a sort of a diesel engine, and the hydraulics power a 63 kg drop weight, which lifts the weight, and then it smashes the window sample tubes. We've got a range of different sizes of window sample tubes. These will go into the ground up to about 10 meters, and then we can further extend the hole with some dynamic probe rods. And on a site recently, we were getting up to sort of 15, 16 meters on a railway embankment. So this is generally used for contamination analysis, and it's we can do up to sort of 4 holes in a day with installations. It's a fantastic bit of kit. It's just about a ton of weight, so we can use it on the railways, on trolleys, and it's a very, very versatile bit of kit. Here's a picture of concrete coring. We use this extensively on the railways and in just general ground investigation. It's a very easy and relatively cheap sort of tool that we can make a hole in the structure. We can also look at the strength, or we can measure the strength of the material behind the structure, and we can sample the strength of the structure itself. So again, a very helpful and useful tool. So there's 2 different types of concrete coring. There's hydraulics, which is this one, and there's also electric. What we want to do is obviously not use the electric one when there's water around. So hydraulic is the most versatile. So trowel pitting, going back to our BS 5930 sort of quote, we're trying to effectively get as much information out of the site as possible. This is probably one of the cheapest methods of investigation that we've got in our toolbox. Depending on the site, we would obviously either choose a 360 excavator style that you can see in the picture here, or you can do a JCB 3CX. Obviously, if it's a big site and lots of trowel pits, the mobilization cost of getting a 360 excavator to the site is negligible. However, if you've just got a 1-day on site, then JCB 3CX that can travel on the road by itself is obviously a better tool. The good thing about trowel pits is we can get a huge amount of sample in a relatively short amount of space. This particular site was up at Wilver, and the material was very granular, and we needed to take a huge amount of sample to make sure that we had enough for the compactions and the testing required. So by lunchtime, I'd probably done 2 trowel pits or 3 trowel pits, and I'd almost filled the back of a Hilux on this particular job. So we need to, it is a fantastic bit. However, what it doesn't do is once we hit rock, that is it. It won't go through the rock. So again, we just need to make sure that we are using the right or looking at the geology before we go to site to make sure that we have got enough depth so we can use the excavator. So what we can also do as part of our main ground investigation, we can undertake in situ testing. So this is a CBR test. So we do a small little trowel pit, and we can run and use the Land Rover as our kentilage. So we can get a very cheap and effective way of doing the CBR testing. On the right-hand side here, we've got one of our technicians taking groundwater samples from the borehole that we've taken. So again, this is what we want to try and do, is get as much information from the boreholes that we've just undertaken. So very briefly, we've got different types of installations. We can have a flesh cover with groundwater and ground gas installation, and then one with a raised cover. Again, if it's in a very vegetated area, we'd obviously want a raised cover, and it's easy to locate. Flush cover is a better way of doing in an urban environment or a trafficked area. On the right-hand side here, we have some inclinometers. This is when we've got a slope that maybe is failing. So when we're using our slope climbing rig, we can drill boreholes, hopefully to find the base of where the failure is, and then we can install the inclinometer. One of the things we need to make sure is the depth of the borehole goes beyond the depth of the slip surface, such that when we come to install it, we can actually monitor exactly where the slip surface occurs. So another very useful tool that we've got is static cone penetration testing. This is when we push a probe into the ground, and we then have an algorithm or a calculation of skin friction versus end bearing resistance, and that will allow us to give a summary of the ground conditions that we are going through. However, this doesn't retrieve any samples, so again, it's a very useful tool, and we can cover up to 100 meters a day. However, we do need to sort of substitute, let's say, the cable drilling with it, so we can correlate the examples that we're getting of the results from the CPT tests. So on the left-hand side here, this is actually in a rail environment. So again, this is with a company called In-situ, and they did a fantastic job. And we were doing sort of 8 or 12 of these tests in a shift, and we did it was very pleasing for Network Rail. As a ground engineer, these are some of the sort of the shots of you doing your work. This is one of our engineers sort of logging on a data tablet. So we're recording the data straight away. That gets uploaded to our clients so they can start scheduling the testing almost the same day. This is on one of our larger sites where we're able to sort of get our cores out and log them, and in discussion with our colleagues. Below here is on one of our rock stores, and one of my other colleagues is undertaking a sort of trial trench and logging a trial trench. So these are the sort of environments you'd be working in if you were a ground engineer. So just sort of a very brief summary, or just a recap on what we've just talked about. When we are sort of asked to go onto a site and we're asked to do trial pits on a hard standing surface, I desperately try not to do this, because this involves a lot of extra work, and it involves the reinstatement of this, which adds another day or two to the duration of the works. If ever you're offered or you're asked by your client to do some trial pits in a hard standing area, I would desperately try and get them to undertake window samples, and we're needing a much smaller hole, about 1/2 meter by 1/2 meter, and we can reinstate that very easily and effectively. If they are looking for larger samples, then we will do that in the soft ground areas to the right-hand side. However, if we would do window sampling in this site on the right-hand side. On the left-hand side, if we came to site with a window sample rig, we dug our starter pit down to 1.2, we would very soon realize that we would refuse at the 1.2 meters depth, or even less than that with this material, just through the made ground. So again, window sampling is not the right effective tool for this, and it would refuse. We wouldn't get the information we need. We'd have to go away and come back with a cable, with a trial pit, with a JCB 3CX on this. So again, it would be it would cost money to come back to site. So again, we need to look at the geology and anticipate roughly what material we're going to be going through before we go to site. So we've got all of the information from site. What do we do with it next? Hopefully this information will then go to our designers. They will then schedule the testing. We will then undertake the testing within one of our 4 UKAS accredited laboratories. We've got a huge range of testing facilities, so we can test any sort of material you require, but we need to make sure that all of that material, there's enough material that we can test. So that's very important. So just a very quick shot about our red lab up in Castleford. So this is where we can test any impacted material with asbestos or hydrocarbon contaminated material. So we can do materials testing, we can do soil testing, and it's in a safe environment. So we can then reuse that material on site. So all of our data gets put into a sort of a package called GINT. There's also Holebase out there, but we personally use GINT. This can then be put, all of our engineers' descriptions gets put into these logs. All of the testing gets put in. We can then export that into AGS4 and offer that to our clients. We are taking a huge amount of sort of care and attention when we come to the rock core that we bring out the ground. We take photographs of it before we do any logging of it, so we get a true record of as best we can from the ground, and then we can always go back to that, and that forms part of our report. So what we want to do is, when we come to doing a ground investigation, we do our desk study to begin with. We get all of the plant and equipment together. We use the right equipment for the site work. We then undertake all of the testing, reporting, and data. And hopefully, if we get that right, everyone's happy and we get it right first time. Sorry. And lastly, I just want to let everyone know that we've recently updated our Engineers Quick Reference Guide. There's a new update, May 2022. There will actually be an August one, but it is just about to go out. So again, if you wait a couple of days, I may be able to get that out for you. So bear with us on that. So I will open up and put the camera back on, and hopefully over to Jim will come back on and we'll be answering your questions.
Yes, thanks very much, Eric. Hopefully everyone's found the talk of interest. So what we're going to do now is have a look at some of the questions that we've got posted here. So here's the first one: sonic drilling. Yes. Are you finding more clients asking for it, or are you suggesting in areas where you know conditions are going to be difficult? So that's quite a good question. Structural soils have only just started sonic drilling in the past, I don't know, what, 1 or 2 years or so? Yeah, 2 years roughly. It has been asked for more, but also we were working on a job for a flood alleviation scheme up in Kendal, and we were initially required to go with cable with rotary follow-on. However, the cable just wasn't giving us the penetration or the rate of penetration that we needed for the client's program. So what we actually did is we talked with the client and agreed the additional cost of the sonic drilling, and we brought the sonic to site, and they were extremely happy with the recovery and also the progress that we were able to make. So it is being asked for more and more, and there's a lot of other people out there that have brought sonic into their arsenal as well. So yes, thank you. What can I add to that? I mean, with sonic drilling, it is quite a lot more expensive than other drilling techniques. But in certain ground conditions, I think you have a bit more certainty that you're going to recover sample. So even in sort of very weak rocks, pebble beds in the trials, for example, which are very difficult to core, then we've had a lot of success with sonic drilling. There's another question here: what's the difference between rotary dynamic sampling and sonic drilling? So it's a sort of continuation of what we've just been talking about. So obviously with the sonic drilling, the sample tubes are vibrated into the ground, and within as the sample is extruded from the barrel, it normally goes into a sort of plastic bag, if you like. The sample is quite disturbed, but generally speaking, you recover all of the sample. And with rotary dynamic sampling, they are sample tubes which are just driven into the ground, so just hammered into the ground essentially. And you can get sort of it compacted, depending on the density of the material. It can be compacted a little bit too. So again, it's a great way of getting the sample out the ground, and it's cheap and effective. However, sonic gives you a better sort of chance of getting the material back as it is in the ground profile. Yeah, just one thing to point out with both rotary dynamic sampling and sonic drilling, and that's you don't recover. It's not a class 1 sample. So if you're looking for samples for laboratory testing, strength testing, and consolidation testing, and so on, then in conjunction with the sonic drilling or rotary dynamic sampling, you also need to take some maybe UT 100 or UT 70 samples between sonic runs. What else we've got here then? What techniques would you recommend for rubbly ground conditions, such as the corn brush? Right. that out.
I would, again, that is quite a tricky one. I would say, depending on how deep we're going, yeah, sonic, and then with rotary follow-on, I would say that's probably the most effective. You could try dynamic sampling, but I think that might not, you might struggle. But yeah, I would say sonic and with the rotary follow-on. What would you say, Jim?
I mean, we've drilled a few sites, worked on a few sites with the corn brash. So the people who are not familiar with that, I was going to say it's a rock. Is it a rock or is it a soil? It's a sort of borderline material with large sort of knobbly lumps of limestone with a sort of clay or sandy matrix. And no one particular technique is always going to work in that sort of formation. And I guess it all depends on what what information you're after. Is it shallow foundations or whatever really? It may be that you could core it with rotary coring, but if there's a lot of matrix, you may not recover all the matrix. It may be that sonic drilling would be effective in that you would recover all of the sample or most of the sample. Of course, the sonic drilling itself will tend to partly destroy or damage the sample. So again, you're never going to recover class 1 samples for lab testing. But no, that's quite a good question, and there isn't, I'm afraid, a
proper answer
to that really. I think the thing to do is to do more than one investigation.
Technique. Yeah.
Between the two methods, then you'll get the information that you're after. Right, shall we just move now onto geophysics? What we've got here, is there any geophysical techniques that have been used to get information about a tested site? Not quite sure what we're after there. I suppose this really is comparing information from geophysics testing with other information that you might derive from drilling boreholes or lab testing and so on.
Yeah, I mean, I did this some time ago on the A2 in Blackheath, and we used microgravity to look for sort of voids basically, and the A2 disappeared into a big hole, and they wanted to make sure that the A2 was not full of holes. So we definitely used microgravity as one of them. That we used cross-hole seismics for others. So yeah, geophysics in conjunction with the ground investigation itself is probably the best way forward. So I don't think, going back to the question, what technique, you need to speak to a geophysicist. Again, it all depends on the ground conditions that we're in. Some techniques, the EM61, the EM31, they all will differ a little bit with the ground conditions. So you do need to speak to one of the geophysicists to make sure that we bring the right bit of kit to the ground, or they'll bring a range of kit and then find the best one and do a little trial before we do the main works. And I think, again, that's with all of the ground investigation information. If you've got the budget allowed, then each bit of equipment does have positives and negatives. So again, a range of techniques. So let's say the CPT truck is fantastic and give you centimeter by centimeter detail. However, it does need to have the cable percussion rig adjacent to at least one of them, so you can compare the results that you get from the CPT truck to the actual ground conditions you're encountering on site.
Okay, thanks for that. There's a couple more geophysics questions. So one of them is do structural soils do geophysics? So I'll very quickly answer that. The answer is we do and we don't. So we do borehole geophysics, and Eric showed a picture of us doing some wireline geologging in a borehole. So that is something that we ourselves do. For surface geophysics, I don't know, some of the stuff that Eric's just been talking about, then we would call upon one of our sister companies within the RSK group, the RSK geophysicists, who are a well-established company, and would get advice from them. And then there's a question here, in the future, do you think geophysics could replace invasive drilling for geotechnical investigation?
I don't think it can. I mean, not with I'm not on the R&D side of geophysics. I mean, it would be fantastic if it could. However, I just don't think it's got the the level of detail. I mean, speaking to my geophysical colleagues, let's say GPR, there's a huge amount of knowledge that needs to go behind the GPR sort of interpretation, and that takes years of experience. So all geophysics is going to give you is a lot of data, and it's down to the knowledge of the person that's interpreting that data. So I don't think it can be a fantastic addition, and it can as we've said before, it can delineate part or sort of reduce maybe the scope of the ground investigation to target certain areas. But I don't think it will replace the ground investigation as such, but it will. Maybe techniques will get better. Maybe you can reduce down the amount of intrusive works, but I don't think it will ever replace it sort of without the intrusive work as well. So I think we've got a job yet, Jim, for the next few years at least.
That's good. I think with geophysics, often they will highlight things like differences in density and so on in the ground, which are then interpreted as being various features. But ultimately, people would still need to physically investigate the features that have been shown up. So looking for mine shafts, for example, you may find some sort of feature which you think is a mine shaft, but of course you would then have to subsequently go and investigate that. Where are we now then? This is a long question. Is there a particular technique you would recommend for investigation within a building interior to limit arisings and associated mess? For example, investigation with a controlled environment storage warehouse.
I would say, yeah, yeah, sorry, carry on.
So I was just going to say, and I'm aware a couple of years ago, we did do an investigation within a food production factory, which we did use window sampling, I think, as you've just suggested. And I think there we hired in a tent or something and did all the works within this tent, so to prevent the spread of dust and so on.
I've worked in, this is how long I've been around for, I've worked in a rank Xerox factory, and it was full of photocopiers, and we had to work in a sterile environment inside a tent with a rotary rig, and that was extremely hot and difficult. But yes, we worked inside a tent, and that was rotary rig with water and flush, and we just had to make sure that we cleaned it up as we went along. Yeah, it was a complete nightmare, I'll tell you that for free.
I mean, we can work in lots of these environments, but I think what people need to understand is, it slows everything down. There's extra costs for the equipment and so on. So it will have an impact on the cost of the investigation. Ultimately, how important is it that you find that information? If you really go out for the information, then it may be that whatever operation is being carried out in the building has to stop temporarily while the investigation is done. It's quite a difficult. I mean, it does all boil down to cost, really. I guess. Ultimately, you can do anything if the money's there to pay for all the extra time and equipment and so on.
Before we run out of time, can I do a little plug for our Engineers Quick Reference Guide?
I do, yes. There is a question on that.
Good.
I think, where can I get my Engineers Quick Reference Guide? So you might.
Thank you. That's perfect. So you can download this from our website, free to everybody in the industry. We've actually just edited another version. So this one currently is May 2022. I'm going to try and bring out a August/September version, and this has actually been reviewed by Dave Norbury. So we've actually had Dave Norbury look at it and add some constructive comments, which we've included. So if you want to wait a couple of days, well, you can download both. You can download the May 2022 copy, and also hopefully our August /September version. So that will be coming out very, very soon. So watch this space. Thank you very much.
If you're not familiar with this Engineers Quick Reference Guide of ours, it's full of useful information on soil and rock description and core barrel sizes and casing sizes and all the different laboratory testing techniques and sample requirements for different tests and so on. So it's a very, very useful sort of aid memoir for engineers when they're out on site, or even elderly people like myself.
Like ourselves.
I have one on my desk all the time. So we've got time for a couple more questions, I think. So here's my favourite question of the lot. When might you do trial pits as opposed to window sample holes? That is a very big question, and we could talk forever. Do you want to start, Eric?
Yeah. When would we do trial pits? If your site is a lovely greenfield site and you've got plenty of space and the reinstatement issues are not quite as critical, trial pitting is the best tool for the job. It's lovely on a nice sunny day in the middle of the countryside, beautiful views. It is fantastic, but also being serious, you can get a huge amount of sample very quickly and effectively, and as long as the groundwater table isn't that high. So if you've got a high water table and then the pit starts collapsing again, that's when you don't really want to be using trial pitting. The one downside of the trial pits is that you can't really do in-situ testing. So the in-situ testing can be done with a hand shear vane inside the bucket from depth or up to 1.2 using extension pieces. So you can get a good amount of information from trial pits. It is effective. When Jim and I were starting out, you could probably do 8 to 10 trial pits in a day very easily. Unfortunately, now it seems that we aren't able to do that just through the amount of geoenvironmental testing that's added onto things, and that just takes time filling in the pots. But we could cover a lot of ground in a very short amount of time. So, Jim, would you like to add to that?
What else can we say? In window sample holes, we can put in groundwater and gas monitoring installations, which we can't do in trial pits. If you need to collect large bulk samples for earthworks testing, compactions and so on, then you have to do trial pits, because you just won't generate the amount of sample from window sample boreholes. You can do SPTs in window sample holes. You can do soakaway tests in trial pits, which you can't do in window sample. So there's many reasons why you might do one against the other. And one of the things, which Eric has said a few times, is you've got to bear in mind the environment in which you're working. So if people want us to excavate trial pits in the middle of a nice concrete surface, hard standing, at an industrial premises or something, you've got to reinstate that, to a very high standard. So people just don't really understand the extra time and cost of doing that. We can do that, and that's fine. We'd love to do it, but it will be very costly. So you just need to bear stuff like that in mind. Right, I think we've probably got 1 minute left or thereabouts. And there's another question up here. Oh, it's a very simple question, but again, there's not one answer to this, and that's how deep can a cable rig drill? I think you did say in your slide 60 meters, but that's not all the answer, really.
No, it is. It all depends on the ground conditions, the amount of testing that we need to do. If we've been able to reduce down, so let's say the client is looking to get 60 meters, we then do need to start maybe in 8-inch or 12-inch casing, reduce down to 10-inch, 8-inch, 6-inch, and then, so it is a big process. So we'll happily do it, but it does need to be the right conditions, right ground conditions. In London clay, it's not really a problem at all. However, if it's sort of chalk, we may struggle, certainly when the chalk starts to get into harder material. But yeah, so Jim, you're more than welcome to jump in on top of that.
I am aware of boreholes being drilled to sort of 80-90 meters with a cable rig. That really is the exception. So I wouldn't want anyone to go away thinking that that would normally be achievable. So 60 meters is a very deep cable cushion borehole, and it's no mean undertaking to drill to that sort of depth with a cable rig. Is quite a proposition, really. Takes a long time, it's costly, it's very messy, you need lots of room to work in. Certain ground conditions, you just wouldn't achieve it. So, you know, you need to speak to your GI contractor, discuss with them what your requirements are, and make sure that you know, you're not asking them to do something that's clearly not achievable. Most cable drilling will go 20, 30, 40 meters, and that's probably sort of typical depth. Much deeper holes, you need to sort of step back and have a think about what, you know, do you really need to go to that depth? What information do you want? Is an alternative and so on. Right, I think we sort of got to the end of the time. There's a couple of questions unanswered, I'm afraid. What we'll do is anything that's not yet been answered, we've got all your emails, so we'll answer by email. There's someone asking if we can use some slide photos for teaching purposes. We'll have to have a think about that, and we can talk to you. Someone's asking about CPD certificates. We'll have a think about that, and I'm sure we can provide that. If you come up with any further questions, then feel free to email either myself or Eric. We did have emails just earlier, yeah. Or the generic ask@soils email address. Here we go. So ask@soils is a general email which is monitored every day, and if you want to give us some work, email us on that, or if you've got another question, email us on that, and we'll try to answer. So that's us done, really. So all I need to say now is the next technical talk in the RSK Technical Talk series will be delivered by our colleagues Toby Gibbons and Melissa Fox of RSK Asbestos, and that's titled Asbestos in Brownfield Development. So thank you very much for attending. Goodbye.
Thank you.